Okay, so let's find 2 points on this line that we can use to find the slope. I'm just looking maybe right here. It's kind of easy. So 0, comma, these go by 2, 2, 4, 6. I'm just going to round. I'm not going to worry about any decimals. So it's not going to be perfect. So maybe 0, 7. Might be 0, 7.7 what, but it doesn't matter. Actually, this one looks good right here. Again, it doesn't have to be one of the points, but this looks good. How about 6, comma, where is this at? Looks like at 15. Okay, so 6, comma, 15. And I'm going to use these 2 points to come up with our equation of the line. So to find the slope, which is rise over run, how do we find the slope between 2 points? y2, good. y2 minus y1 over x2 minus x1. So let's go ahead and find our slope. So the slope is, so let's use 15 minus 7 over x minus x, so 6 minus 0. Okay, so this is, what do we have? 8 over 6, which actually reduces 4 to 3. Okay, probably not perfect, but close enough. Okay, so that's our slope, our approximate slope of this line. So we need the y-intercept. So, although I can look at it right there, if we didn't pick this as a point, we would do this. Y equals 4/3 x plus b, or y-intercept. So we need to find this b. So how do we find this b? We plug in a point. Okay, I could plug in this for x and y. I could plug this for x and y. Which one do you want to plug in? Looks like this one's a little easier. So plug this for y, that for x. So 7 equals 4/3 times your x, which happens to be 0, plus b. So that's 0. So what does b equal? 7. Okay, so b is equal to 7. So we have our slope and our y-intercept. So here's our equation of our line. So y equals 4/3 x plus 7. Okay, so there we go. So by hand, to approximate what the line, the equation of the best fit would be, is right there. Okay, so part C, okay, using the linear regression command on your calculator, actually there's no command on there, but I'll show you exactly how to do it. Let's find the equation of the best fit line. Okay, so on your phone, okay, let's get this open. All right. Okay, so we need to plot these points. So we're going to make a table here. So where it says there's a little plus there, okay, go ahead and push that. Okay, what do you think we're going to choose? Table. So push table. Okay, and it allows us to input all this data. Okay, so push the plus and pick table, and there we go. So we have x1 and y1. Okay, so let's input these values for x, put 0, so type in 0. You can go down and type all the x's and then go back and type all the y's, however you want to input these. So I'm just going to do the x's, so 0, 3, 6, 9, 12, and 15. Okay, and then I'll go back up, type in the y values that they had, the average weights, so 0, 7.2, 12.2, 15.1, 19.4, 21.5, and then 26.3. Okay, so put all those in there. Okay, and let me, 15 is 26.3. It's right on your chart, right on your paper. Okay, and if you zoom out, it plotted those as I typed those in, but there are the points plotted. Okay, did you guys get that? Okay. So now once we have all the data in there, we want our Desmos to predict or find our line of best fit, the equation of our line, y equals mx plus b. Okay, so go ahead and on another line here, so just push it. So line 2, just push it, it'll scroll it down right to where you want it. Okay, we use the variables y1 and x1. So if we're going to use those, we have to put a little subscript on it. So let me go back down. All right. So I want to type in a line which is y equals mx plus b. Okay, so I'm push my ABC button so I can type in some variables here, some letters. So we have y, but we need 1. So let me go back to my numbers and just type in 1, and it gives you the subscript right there. So y1. Okay, and then I don't want to push equals because this is an approximation. We want it to approximate it. So I'm going to push ABC again, and then you'll see this little squiggly line right there. So this will be approximately equal to. So type that in. Okay, so y1 and that little squiggly line equals mx plus b, because we wanted to try to graph a line. So m is our slope, so m, and then x1, so x, I'm going to type my number in, so 1. So right now I'd actually started drawing that, but I need my plus b. Okay, so plus, back to my letters, b, and there you go. So it draws a line. It's pretty neat. Okay, draws a line of best fit. Okay. Just here's my table right there. So I just kind of go up a little bit, and then just touch right there, and it'll start another little screen there. Okay. In fact, if you want to do line 3, line 4, different things, you can keep going. Okay. Okay. So now, yeah. So now, if you scroll up a little bit, it gives you the slope of the line. It's kind of hard to see, and also the y-intercept. Okay. So let's go ahead and write this line down. So y equals slope, and we'll round to the nearest tenth. So 1.2 x plus b, which is 7.8. So that's our line that Desmos came up with, line of best fit. Okay. Did we get that? All right. And then we can use this equation to predict other things. And I think on the other side of this paper, we're going to do that. So D, okay, use your calculator to determine the linear correlation coefficient. Okay, fancy word, but okay, round nearest thousands. How can you predict this value in the, okay. So let's look at, in this information, it gives you this r squared, and it gives you this r. This r value is this linear correlation coefficient. Okay, and our r they gave us was, what is it? 0.995. Let me tell you what this means. Okay, the closer to 1, so if it's between or close to a -1 or 1, the correlation is very good. Your line predicts where all your data points, it's very good. So I'll just put an excellent correlation. So excellent correlation. Okay, if it's close to 1 or -1, and this is close to 1, 0.995. Okay, if it's 0, then what do you think that means? There's no correlation. Okay, your dots may be all over the place, and okay, it's not even close. So no correlation. Okay, so it's just a number that's relative. So if you got something like 0.7, the R value is 0.7, then it's kind of strong, but not as strong as 0.9. Okay, if you got 0.1, then no, it's probably not very good to use this equation to predict anything, because it's not a very strong correlation. Okay, questions so far? All right, so let's turn this thing over. Okay, so number 2 says, using the equation that your calculator produced in exercise 1, which we did, predict the weight of a baby girl after 10 months. Okay, round your answer to the nearest tenth of a pound. Okay, so 10 months. Okay, so let's go over here. So at 10 months, we'll just kind of figure out what it predicts. So we're using the same equation. So for 10 months, what is our x that we're going to plug in? 10. Okay, so if we want to type in our number, actually I'm going to type in m instead of 1.2 because m, if it's defined there, it uses this value right there. Okay, it's a little closer than 1.2. And if I use b, it uses that. Okay, so I'm going to plug in 10 for x. So let me go back over here. So it's m times x plus b. Okay, but x, okay, we're going to, oops, let me just cross out. We want that to be 10. All right, so let's go down to another screen. So go ahead and below that, just touch it there, and it goes to slot 3 where we can start entering some stuff and do some more calculations. Okay, so if I type in m, it's that stored value. That's our slope. Okay, times 10. I think we could just type in 10, or you could put times 10 if you want. I'm just going to put times just in case. But times 10, it already starts calculating that. And then plus b. Plus b. Let me go back over here. B. And there we go. So what does that give you? 19.99, so probably close to 20 pounds. Okay, so 10-month-old baby, if you try to go back over here, so about 20, actually that's pretty close on this line right there. Okay. Okay, we're able to get that? Okay. Okay, the use of a model to predict outputs when the input is within the range of known data is called interpolation. Okay, interpolation tends to be fairly accurate. What does that mean? Okay, we wanted to, on this last problem that we did, a baby that is 10 months old. Well, 10 months old is within the data that they collected, right? 10 months. And then, so this is an interpolation. If we wanted to predict a baby with age of actually even 16 months, okay, that's outside of this set of data. That's called, and I'll go over here, it's called extrapolation. Extrapolation. Okay, so interpolation. So let's use the equation that your calculator produced. Let's predict the weight of a baby girl after 2 years. Okay, so how do we do that? How many months is that? 24. Okay, so m times 24 plus b. So go ahead and do that on your Desmos phone calculator. So you would go to another screen down there and do the same thing. I'm just going to put 24. No, it gives you that. So I got to go times 24. Oops. 24 plus b. Okay, and what does that give you? 37 something pounds. Okay, so 37.017 something pounds. Okay, so 2-year-old predicting would be 37 pounds. Okay, the use of a model to predict outputs when the input is outside of the range, which we just did, of the known input data is called extrapolation. Okay, models are most helpful when they can be used to extrapolate, but tend to be less accurate. Why do they tend to be less accurate? Well, right in the set of data, this is the actual data. Well, this is a baby age month. So as soon as they start getting older, do you think it's going to follow this for the rest of their lives? Probably not. Okay, but just right in this data, it's pretty close. Pretty close. Okay. Okay, number 4. Biologists are trying to create a least squares regression equation. That's basically the same thing as a best fit line relating to the length of a steelhead salmon to their weight. Okay, 7 salmon were measured and weighed with the data given below. Okay, so let's find our equation for this. So let's go ahead and input this table. So how do I get rid of all these things here? Because I want to start over. Okay, we could press X. Press X as it start clearing it. I think we could push maybe the setting, delete all. So this button right there, push delete all and you're cleared. Okay. All right, so let's go ahead and put this table in. How do we do that again? Okay, push the plus sign, push table. Okay, go ahead and put that in there. So the X ones, so 22. So put all those in there. 24, 28, 34, 39, 42, 48. Okay, then type in the Y values. 8.43, 4.46, 7.08, 14.21. And as you're typing these in, these will probably be graphed as you're typing them in. You could zoom out a bit. Okay. Let's see, so 39, 22.19, 31.22, 40 is 35.67, 35.67. Okay, and there we go. Okay, and if we want to change our window, we could definitely just zoom in, zoom out. Okay, but sometimes the numbers are real big and you don't want to go that far. So if you push, let's just practice this. Push the wrench symbol up in the top. Okay, and then it has X-axis and Y-axis. And so let's just, so our X numbers, we have 22, 24, goes all the way up to 48. So how about we go from maybe 20 to maybe 50? So just tap on that. So the low is 20, and then the Y is, or the higher upper one is 50, and then just click off of that. And so that just kind of, your window goes from 20 to 50, and that covers everything we want. Okay. And you could do the same thing for the Y values. Okay, just touch the wrench up there. Okay. Okay, when you take the SBAC test, Desmos will be on there on certain problems, and then you'll know kind of how to fiddle around with this thing. Okay, so A, let's find the equation. All right, so how do we find the equation of the line of best fit? What do we push? What do we do? How do I get there? Okay, Y equals mx plus b. What do I do? Okay, just touch the next line. There we go. So do I type just Y? Okay, so Y subscript 1, so just type 1. And do I push equals? No, squiggly line. I want to approximate M X1 in the ABC plus B. Okay, and there's our line of best fit. Okay. So you got the salmon, the length, and the weight. Okay, let's go ahead and so let's write the equation. So let's go back. So the slope, so it's y equals, it's to the nearest 100th, so 1 point, how would you round that for our slope? 1.33, nearest hundredths. X plus b, which is actually negative 27.99. Okay, so y equals mx plus b. Okay. Okay, part B. Okay, using your equation from part A, determine the expected weight of a salmon that's 30 inches long. 30 inches long, so somewhere in here. Is this an interpolation or extrapolation? And why is it an interpolation? It's in the set of, okay. So we'll do slope, so M times 30 plus b. So type that in. M times 30 inches plus b. Okay, so if they caught a 30-inch salmon, how many pounds would they predict that would be? 11.78 pounds. Kind of makes sense, somewhere in there, 30. There we go. So we use this equation to predict. Okay, C, using the equation, determine the expected weight of a salmon that's 52 inches long. Okay, so go into another screen there. So M times 52 plus B, and using this same model, so M times 52 plus B. Okay, how many pounds? 40.9, we'll go 5 pounds.
Mine doesn't show the gray box in the bottom right corner.
It does not have that?
No.
I have to see what you typed in. Do you have this up here under your table? Do you have this where it says M is equal to 1.3?
I couldn't put that either.
Okay, so that's got to be in there, that's why.
Yeah, I couldn't put
So,
that. I put that, but it didn't.
yeah, we'll go back and make sure you have your table all put in there. Okay. Okay. Okay, in part B or part C, did you, in which part did you use interpolation? This one was interpolation, okay, because the 30 was within that, and then 52 inches, which is outside of that. Okay, this is extrapolation. Extrapolation. Okay. Okay. Let's turn it over. Okay, so this is actually part of your homework here. Okay, so which of the following linear equations would best fit the data shown below? Actually, let's go ahead and input that. So I'm going to clear everything. So delete all. Okay, go ahead and input that. We'll answer this. We'll do a couple of these, and then we'll come back. We might do the next lesson, or we might look at some of these.